One of the most famous was the Mickelson-Morley experiment in 1887.
No. Tell us about that.
Well, they used light beams to measure whether the Earth was moving, and they found that there was no movement. The Earth has to be moving 30 kilometers per second to complete its annual revolution, and they found out that it wasn't moving in a very precise. Mickelson could have calculated it to 1/100th of what he got in his experiment. That's how sensitive his instruments were.
What did the experiment involve in terms of apparatus, so we can get a concrete understanding of what they found?
If the Earth is moving around the sun, and we shoot that light beam in the direction that the Earth is moving, okay, and then we shoot another light beam perpendicular to that, well, the one that's in the direction of the Earth's movement should be impeded in some way if it's moving through space, whereas this one is going perpendicular would not be impeded.
Why not?
Because it's not going through space. It's just going north and south. Okay? And what they found, they expected to have a 30-kilometer difference between these two light beams. There was no difference. So the natural interpretation, and even Einstein admits this, Mach admits this, Born admits this, the natural interpretation is that the Earth isn't moving. So how do we get out of that? Well, you invent special relativity. And now you say, well, the reason that light beam wasn't affected when it went toward the motion of the Earth is because the apparatus shortened.
Huh?
Yeah, Michelson's apparatus shortened as it was going with the Earth in its orbit around the sun.
No, wait, you're telling me that the contraction of mass was invented to explain away the results of the Mickelson-Morley experiment?
Yes, and that's what my book will tell you, and it's been admitted by all the scientists.